Hello, welcome to Maths with EJD. In this video, I'll be talking about depth first search traversal algorithm. But of course, since the idea of traversal is coming for the first time in this graph theory playlist, so it's important that we first of all talk about traversals. Traversals. Okay? So, I think there's an English word like traverse. So it's more like going around. So that's the kind of concept of traversals. So in graph theory, traversals are systematic ways. They are systematic ways of visiting, systematic ways of visiting all the nodes, all the nodes or vertices, all the nodes or vertices, all the nodes of vertices in a graph. Okay, so those are traversals. All right. Now, so to visit all the nodes or vertices in a graph is more like visiting all the districts of a community or all the wards in a city or all the local governments in a state, depending on where your location, or probably all the counties in a state, or all the provinces of a country, or all the districts of a province, or whatever divisions there are, right? So, in graph theory, right, the two most common traversal techniques, the two most common traversal techniques, uh, tra okay, okay, I guess that has to go. The two most common traversal technique are what is called the depth first search and the breadth first search. So they are the first one, the depth, the depth first, the depth first search, that is DFS. So it's an algorithm, the depth first search algorithm. Okay, that's the first one. And the second one is called the breadth. So depth and breadth. The breadth, the breadth, uh, the breadth first search, which is BFS algorithm. Okay. Now, each of this, each of this actually has its unique characteristics. Each each has unique characteristics, unique characteristics. Okay. They also have their use cases. They have their use cases and implementations like that. Use cases and implementations. Okay, so our focus in this video is on the depth first search algorithm. So let's focus on that right now. So, so the depth first search or DFS. So depth first search explores, it explores as far down, as far down, it explores as far down a branch. So if you take a branch of a graph, so DFS explores as far down the branch, as far down a branch as possible before backtracking. So you can backtrack in DFS before backtracking. Before backtracking. Okay. Then it uses a stack-based approach. It uses a stack-based approach. It uses a stack, a stack-based approach. Is a stack-based approach, and that can be either explicit, so that's it can be the stack-based approach can be explicit, so it can happen explicitly or via recursion. Okay, so that's how that works. Now, let's talk about the steps involved in depth first search algorithm. So let's say steps, steps, steps in depth first search algorithm. So the first step here, of course, you need to pick a starting point. So step one, you start, you start at the root. Start at the root node. Start at the root node or or an arbitrary or an arbitrary node. So the root node would usually be, maybe a well-known starting point. So talk about the situation where you have, maybe you do a business and your home is your base. So your root node will be your home. Okay. Maybe you supply what a cake to all the people, to all the houses in your community. So your home is going to be the root node. And apart from that, you can just pick any arbitrary node in the graph. So, or an arbitrary node, that is if the graph is unconnected. If the graph is unconnected, okay, you pick an arbitrary node if the graph is unconnected. Trying to manage that space. Okay, I think it's fine. Yeah, that works. Okay. So that's the first thing you do for depth first search. So the next thing you want to do now is to mark that node as visited. Okay, that's first node you started with. Two, you mark the node as visited. Mark the node, mark the node, uh, mark the node as visited. Then the next thing is you explore one of its neighbors. Explore one of its neighbors. Okay. After that, repeat steps two and three until all neighbors are visited. Okay. So step three is explore one of its neighbors, right? Then we go to step four. So step four, you repeat steps two and three, repeat steps two and three until until all neighbors are visited. Until all neighbors are visited. Okay. Then step five, then you backtrack. Backtrack, backtrack when backtrack when no unvisited. Backtrack when no backtrack when no unvisited. When no unvisited neighbors. Backtrack when no unvisited neighbors are left. When no unvisited neighbors are left, and continue the process and continue and continue the process. Okay. So those are the five steps. Well, I mean, all this may still be looking vague, but let's take an example to drive home the point. So imagine this example now. So we have node A. Let's say this is your house. Your house is at A, and then you have two neighbors, B and C, and then one of your neighbors has two neighbors. One of your neighbor B rather, has two neighbors, D and E. So the question is, how do you visit all your neighbors? How do you supply maybe cake or whatever you're supplying to all these neighbors using the depth first search algorithm? So, I mean, if you follow the steps, right, the first thing is to start at the root node. The root node is your house, okay? That's, let's assume your house is at A. Of course, you can also start from any arbitrary node. So start at the root node, which is A. So in that case, you can already indicate A is, A is done. So where do we go next? So after going to A, right, um, you mark the node as visited. So the next thing is you explore one of its neighbors. So let's imagine we are exploring your neighbor B. So explore your neighbor B. That's supply to your neighbor B. So, and of course, you are going to mark that as visited. So you see that your neighbor B is on a branch. So it's on, um, it looks like you belong to the same street somewhat. So you want to go down that street that lead down to D. So, but of course, you visited B, so you indicate that here already. Okay, you visited B. So for depth first search, right, it says that it explores as far down a branch of the graph as possible. So if that branch is the road linking A, B, D. Now, so you go down that long branch, okay? So you come so after B, you come all the way down to D. So you can now mark D as visited also. Now D is visited. So you also indicate that here that okay, from A to you from your home you visit B and then you visit D. Now, backtracking is another feature of the depth first search. So the next thing is since you have come to the end of that street, down the street. So it means you travel down the whole street, then you can now backtrack. So you can come back to B and now visit D. Okay. So you come back to B and visit E rather. I said D. So visit E. So that means after D now, you visit E. Then again, after that, you go back home and link the road to C. So the edge to C, then you visit C. So C is going to be the last place you visit. Okay. So by doing this, you have traversed the whole your whole neighborhood and you have supplied cake to all of them in the order A, B, D, E, C due to the depth first search algorithm. Okay. So A, B, D, E, C. That's one example. So I like to take another example so that it can be abundantly clear how this works. So let's go for that. Imagine another example. Say you have in this case now, you are in a neighborhood where your house is house number one, and then house two, you have house two, house three, and then you have house four, you have house five, house six, and there's also house seven and house eight. So you know, your house is you have a neighbor, you have neighbor one and four. Your neighbor two has neighbor three and five. Your neighbor then your neighbor three now has neighbor six and seven. Neighbor seven has neighbor eight. But then you discover that okay, of course, four has neighbor five, five has neighbor six, like that. So how do you use the depth first search algorithm to visit every house in your neighborhood in this case now? So in this graph now, so your starting point is your home. That's one, right? So indicate that one. So you're starting from one. So where do you go next? Based on the depth first search, it means so you can go to four if you like, really. But I think usually you want to go the longest you want to travel the longest street first. Then after that, you now start backtracking. So imagine to visit the longest street, so it means you are going to visit neighbor two next. So after your house, you go to neighbor two, supply them whatever you're supplying, maybe cake or whatever. Then you have visited neighbor two. After neighbor two, then supply neighbor three. So you want to go. So depth first search means go down that long streets first. So after two, you have visited three now. Then you visited three. After three, where do you go? So you go to seven because you want to travel on that longest street, first of all. So after three, you're going to seven. Okay. After three, you're at seven. Then after seven, you travel again to eight. Okay. So after seven, you have gone to eight. Now, based on the depth first search algorithm, now you have come to the end of that street. So it means that you can now begin to backtrack. So as you backtrack, any first house you see, any house you see first, that you have not visited, you just go there first. So you have gone to the end of the street. So you go to seven. Seven has no neighbor. Oh, okay, well, seven has no neighbor you have not visited. So, which, and of course, so you can backtrack to three. So three has a neighbor, which is six that you have not visited. So you can now visit six. Okay. Supply six, what you have to supply them. Okay. Um, that is six. Then you backtrack to two again. You backtrack to two again. I guess maybe I should use like I don't know, this. Maybe so you're backtracking to seven, you backtrack to three, and you visit six. Now you're backtracking to two. So backtrack to three, you visit six, backtrack to two, and you visit five. Okay. So something like this. So you visit five now. Then again, so after six, you're reaching five. Then after that again, you backtrack to one, okay? And you see that one has a neighbor you have not visited, which is four. So you visit four now. So something like this. So you end up with your next door neighbor. And then that is how the loop is. You go to four. And that after that, you can go back home because you have visited all the houses in your neighborhood with your merchandise, and that is it. So the path is 1, 2, 3, 7, 8, 6, 5, 4 using the depth first search algorithm. So, in that case, it is important to talk about the kind of thing, the characteristics of depth first search. Okay, so let's talk about the some characteristics of the depth first search algorithm. Okay, so key characteristics, key characteristics of depth first search. So the depth here is like you go down, you take the street and go all the way down the street before moving to other places. So one of the characteristics talks about the time complexity in computer science, right? Talking about time complexity, you're talking simply talking about the length of time it takes for an algorithm to run based on the inputs, based on what you input into the algorithm. So that's the idea of time complexity. And you have different time complexities. It can be constant time, it can be linear time, it can be log linear, it can be all kind of things, cubic, exponential, factorial, and things like that, depending on how much time it takes for the algorithm to be executed. So, and we use big O to represent that. So the time complexity for depth first search algorithm is O of V plus E. Okay, where where V is the V is the number of vertices. V is the number of vertices or nodes. V is the number of vertices or what you call nodes. And and E is the number of edges. Number of edges. Okay. So that is the time complexity for the depth first search algorithm. Okay. Then apart from the time complexity, we also have what you call the space complexity. That's the second characteristic here. So we talk about space complexity, still using the big O, space complexity. Okay. Now here, the space complexity is also is OV. That is big O of the number of vertices. And this is due to the recursion stack. It's due to the recursion stack, or it's due to the recursion stack or explicit stack or explicit stack. Basically, all this is about the backtracking that we end up doing. Okay, so another property is about the applications. What are the applications of the depth first search algorithm for traversing a graph? Okay, so let's talk about that. The applications. So this is very helpful in detecting cycles. We know a cycle is a closed loop in a graph. That is, it's more like somewhere you can get trapped in, and you can't, you just keep moving around the cycle. So detecting cycles in graphs, depth first search approach helps you for that. Detecting cycles in graphs. Okay. So again, it's also good for solving puzzles, solving solving puzzles like mazes. solving puzzles like mazes, because of the idea of backtracking. Okay. Then we have topological sorting. You know, topology is about space, right? Like topological sorting. Topological sorting. That's another application of depth first search algorithm. So with this, we've come to the end of this video. In the next video, we're talking about the breadth first search algorithm, which takes a different kind of approach to this. So watch out for that. And to make sure that happens for you, be sure to subscribe to the channel, hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know if you want me to teach a topic or solve a problem. Then like and share so that more people can have access to this great learning. Till I come your way again. Bye.